Hello community. Let's talk about the future of two trending topics, ChatGPT and Stable Diffusion. So let's have a look at this. ChatGPT, we know you have a prompt and the system provides a text for you. It could be a lyric, it could be an essay, it could be an instruction to do something. You give it a prompt and you have here text to story. ChatGPT currently runs on GPT 3.5. The other one is Stable Diffusion version 2.1. We are here now in mid-December 2022. And you have a technical prompt and you get out a synthetic image. And if I say synthetic image, I really mean it because look, this is the prompt that I need according to Stability AI to get exactly this image. So here we have two systems where you have a text prompt providing a text story and a technical text prompt providing an image. Now you might ask, hey, why you show us those two things? Well, have a look at this. Now, a lot of people are trying to optimize their technical prompt for their synthetic pictures. They want to have beautiful pictures they imagine. So the technical prompt can be quite complex. Therefore, you have hundreds of YouTubers trying to find out the best technical prompt, or to be more professional, you hire people. We have a micro gig economy with platforms where you have people, you give them a prompt, you have now Stable Diffusion executed, gives you a picture, a data labeler qualifies the picture, it goes back, this labeled data trains now a neural network or a GPT. This system now produces another improved prompt and you have here a learning system. Beautiful. So let's look at the company structure of those applications. ChatGPT, we have OpenAI, a for-profit corporation, founded late 2015 by Sam Altman, Elon Musk, Peter Thiel, Amazon. Somehow they collected $1 billion in 2015, and in 2019 they received $1 billion from Microsoft. Headquarters currently located, to my knowledge, in San Francisco. Stable Diffusion is Stability AI, the company, and their headquarters are in Notting Hill, London, United Kingdom. And if you're interested here in this macro gig economy and the data platforms that are specialized to provide data labeling and data annotation, given micro tasks, they just cost about 5 cents, 3 cents. There are different companies. Those human gig workers or human labelers are primarily sourced by Scale AI, Upwork, and a lot of other companies. Scale AI and Upwork are mentioned by ChatGPT in their documentation that their human labelers are sourced from Scale AI and Upwork. Let's have a look at the current possibilities. What are people doing right now? They tried to use ChatGPT to have a prompt to get out a technical prompt. Now the problem is that the system was not really trained to do this, so the performance is really mediocre. A better way, as I showed you, is you go to this micro gig platform and you pay, I don't know, 8 cents per task and you let it run for 1,000 prompts, and then you take the best prompt that you get back. So, but what we can do is you have a prompt, for example, tell me a story about a beautiful girl who, I don't know, find a prince, they found a beautiful house and then they married. And so the ChatGPT now generates the text, the story for you. And I've seen that sentences are taken out now, and with this sentence is now the technical prompt for Stable Diffusion to generate to each sentence or each second sentence a picture. So we get kind of a storyboard. And you know, if we have a storyboard, we already have the technical capabilities to have here a picture, and then we can make here, for example, this person smile with slightly move the head. So we get little film strips From the house, also sunset, and where there's a beautiful marriage. So yes, we have here our little film strips, and you know where it is going. You can produce little clips beautifully, absolutely synthetic. So current possibilities, easy. You riding on a Harley Davidson on Mars. And this is a clip of 10 seconds. No problem. This is within reach what we can achieve. You have stable diffusion in painting, you have the morphing mechanisms. So state of the art, you can generate those synthetic movies, little clips. Now, what is the near future if you have a separated technological evolutions of those two companies and of those two technologies? Now, it is easy. ChatGPT will become ChatGPT 2 or Super or whatever. And I'm quite sure, because if you look at the first chat, that they will have professional editions for Science GPT or Finance GPT or Medical GPT. And the backbone, of course, will be the new GPT-4. So there, I think, is just a refinement, further filters, further development of the algorithms, and some very dedicated system, because you want to grab market size in each of the main markets. Great. Stable diffusion. Well, we will have Stable Diffusion 3 with a specific landscape edition. So you will have a portrait edition with optimum synthetic portraits from human or from your pet or from your loved ones or whatever, and landscape and cityscape and whatever. So I think this is a clear normal evolution if you let these companies run without any further disruptive input. Now, in order to understand what is going on, let's have a look at the theory and the code behind this. Now, in Stable Diffusion, I have 4 videos I did. And here, the first one, here, Stable Diffusion, the blue one, I show you the theory behind Stable Diffusion. Variational Autoencoder, the Latent space, we use a UNet, we use a clip text encoder, and here's the complete theory. Here, I show you the code in PyTorch, where I have a free Colab Jupyter notebook, and I code with you here Variational Autoencoder UNet clip, and we generate a picture really step by step. We build it up from scratch. Now, before we had the diffusion process, we had the vector quantized variational autoencoders. And some of the theory of variational autoencoders I need here when we move from vector quantized variational autoencoders now to the diffusion process. And here in this diffusion process, there's one YouTube video of mine where I show you the images in between. I had a problem how those images in between are generated, but more about this in a second. So these are the 4 videos for Stable Diffusion if you want to understand the theory and the code that you are able to code with me. ChatGPT, I have 2 videos. Here I have ChatGPT and Flan T5. Flan T5 is currently one of my preferred LLMs from Google. And if you want to see here the performance enhancement we can do with code, this is the video for you. And if you want to focus exclusively on ChatGPT, this here is my new video where I go in detail into the step, the theory, how does ChatGPT work, what are the algorithms, what are the methods they use, how they implement it, what is the process from the very basic up to the synthetic text or the synthetic instruction or the synthetic whatever. And you see that here we are talking here about synthetic images, and here we are talking synthetic text. And you can guess where I will go with the further of this video. So what I wanted to focus here, the images in between. This was something that really struck me, because I wanted to have here a look. How is it possible that those videos are generated? And let me show you. This is nice in Canva. I can go into my YouTube videos in Canva in the presentation mode. And here I am. This is what no, thank you, not this. How can it create new picture objects? How is this possible? And the answer is easy. Given sufficiently expressive neural networks, the variational autoencoder Latent space can fix complex data distribution very neatly. So you can expect to see, and this is the most important part here, smooth transitions between the different types of data point in the latent space. And I think this is, for me, this was the point when I understood how those synthetic pictures could be generated. If you want to have a look at the video, I highly recommend it. I think it is instructive if you want to understand the theory, because you have the astronaut riding a horse here in the middle. So you have a picture of an astronaut, you have a picture of a horse, but never happened in history that there was a picture taken with an astronaut on a horse on the moon. So how is the system able to synthesize those data? So in the same schema, you will encounter now on the other side with ChatGPT. Do you remember ChatGPT? They showed us they are training their model in 3 steps. The first step was, here we have a prompt from a database, and a human labeler now writes here the answer to this prompt. Let's say the prompt is, write a poem like Shakespeare. Here, William Shakespeare, beautiful man. And our result is here, a beautiful poem like Shakespeare. Maybe she looked it up in some old English book or wherever. So here we have now our labeled training data set, the response to this prompt. So labeled data set by human, we are talking about supervised learning, and with this new data set, we can now fine-tune an already pre-trained GPT transformer that has read, I don't know, let's say all of the internet. Beautiful. Now, please don't think of this as a classical template, because I've seen comments by viewers that say, this is a template. No, it is not. There is no template. It's an advanced form. Think of it as a path you want to follow. And it will make sense if we apply game theory to this. So this is step number 1. Okay, beautiful. Step number 2. Remember, we have now our GPT-4 transformer, and the same prompt now goes as an input to the GPT-4 transformer, and we get 4 outputs. They are all different. You have a big, a smaller, and a huge output response. And now we have, again, a human labeler, and this human labeler ranks now the result from our GPT-4 transformer. Ranks it. You notice now another time we have a human bias coming in, because how she, her, or whatever ranks it depends, of course, on her knowledge, on her preference, on her views, on her beliefs, where she is living, how she sees the world, and whatever. Applies for all other person on this globe. Beautiful. And then when she ranks it, the system, we have another data set. We have another training data set now. And this is now the new training data set for our reward model, for our R model. So this is step number 2. Beautiful. We have now 2 neural networks trained on this. And you might say, okay, but how is this analog here to this unseen and untaken picture of an astronaut riding a horse? Now, easy. Imagine this was just Shakespeare. Now, step number 3. Step number 3 is we have a prompt never seen before by the system. And now we let the system learn and train. Beautiful. So let's do this. So the new prompt is now, write a poem like, and not Shakespeare, but Shelley. 1792, the United Kingdom, the Great Britain, you know what I mean? And the system has never seen this and has not been trained, fine-tuned on Shelley's. But what we have our supervised and fine-tuned GPT-4 transformer from step 1 that has, in the pre-trained step, already read all of the internet. So our GPT-4 transformer has read all the works of Shakespeare and Shelley. And then it was only fine-tuned on the poem structure of Shakespeare. Beautiful. So here we have an immense knowledge base. But we are lucky because we have another model neural network, a transformer-based neural network. I don't know if it's exactly a GPT-4. I have found no literature about this, but just imagine a neural network. And we have just fine-tuned our neural network here in step number 2 on the best sample of Shakespeare. Remember, we had 4 samples generated by our GPT-4 transformer, and we say, hey, this is the one I like the most, and this, and hey, number 4 is really not that prominent. So, and this has been the best examples of Shakespeare, and now we have the beauty that we can apply it also to Shelley. So let's have a look at this. Remember we were talking about here the policy gradient, and OpenAI did some fantastic work. They developed their own PPO, their own policy gradient, the optimization, and they use this here that these two systems now learn from each other. We are now in the topic of reinforcement learning from human feedback. And this is exactly what happens. This is how you can generate now an answer to a prompt, write a poem like Shelley, where there has been no fine-tuning on Shelley's work. It was only stored in the it's not a data lake, in the cache of our GPT-4. So you see, this is also like here. We have here the work von Shakespeare, and we have fine-tuned, Shakespeare. Here we have Shelley, but a combined picture is now like in the picture case, in the image case, where you have the diffusion process. Now more or less we have the same process going on with here a policy gradient approach, which is of course based on Markov chains. But more about this later. So you see, this is the way to go, and we have here now the way explained how these untaken pictures are generated by the system. And we have here how these unfine-tuned answers on a prompt, the stories that are produced by ChatGPT and maybe ChatGPT-2 are generated with reinforcement learning from a human feedback. Great. Beautiful. To show you the common technology that both companies use, that both applications use, let me step a little bit further out of the system, this 10,000-mile view. With Stable Diffusion, we use here a Markov chain to gradually convert one distribution into another. An idea that's originated, of course, in non-equilibrium statistical physics. And what we do more or less, we have a generative Markov chain, which converts a simple known distribution, here the simplest is of course a Gaussian distribution, into the data distribution using a diffusion process. And if you just have those two sentences, those are the most important sentences. We are operating with distribution and diffusion processes from non-equilibrium statistical physics. And then we define a probabilistic model at the endpoint of the Markov chain. And since each step of the diffusion chain has an analytically evaluable probability, the full chain can be, and this is the most part for if you're a mathematician, analytically evaluated. And as I showed you, the variational autoencoder Latent space can fit complex data distribution of our data very neatly. And this is how it is done. Kullback-Leibler divergence, the delta of the probability distributions, but more about this in a second. If you want to know the pure mathematical structure of variational autoencoders, you have a Latent space, you have a prior probability distribution, you have a family of encoder distribution, a family of decoder distribution, you have an encoder neural network and a decoder neural network, and you have a loss function. And this loss function has, of course, the reconstruction error, the classical error, and then you have the Kullback-Leibler divergence. Keep this in mind because we're going to use this later on. The other part, as I showed you in my video, is here the UNet. UNet, now very simple terms, is for the visual part in the diffusion process. And CLIP, of course, is our classical, typical text encoder. If you know SBERT, you have an idea what CLIP does. Beautiful. The coding of all of this, can I go? Yeah, I can go in, is here. This is a Jupyter notebook, a Colab notebook. It's free. I explained what is Stable Diffusion, and I run with you through all the different elements. I hope to show you here diffuser, inference pipelines, and we really code here a complete process of Stable Diffusion. So if you're interested in a coding here with different scheduler, this is the video for you. Beautiful. Now, coming now to the other side, to ChatGPT. I have here this video where I showed you how ChatGPT works. Can I go in this video too? Yeah, beautiful. And here, yeah, let's stop here. Now, they have given us from Instruct GPT the 3-step process, and I go in detail through the process and try to explain what's going on. But the most interesting part is they use the reinforcement learning approach from human feedback. And you know, the algorithm that is really famous in this, also a control algorithm or an automation algorithm, is policy gradient algorithms. Now, you know that OpenAI have a very specific policy optimization, the proximal policy optimization, or PPO. And from those, they have 2 subsets, but let's forget about this. Just want to show you that they also use the Kullback-Leibler divergence here in their objective function. And it is interesting because you start to see that we use here more or less the same mathematical instruments. And if I tell you there's a beautiful paper about the optimality and approximation with policy gradient methods in the Markov decision process, which is here a significant part of the policy gradient algorithm, you understand that the Markov decision process here from the left side is simply an extension, if you want, in a mathematical way, of the Markov chain, of the generative Markov chain here of the right side. So you get an idea that the future development could be on the technological level. Either those companies go here strictly separate paths and they specialize here in text to image and here text to story, or somebody, wherever. I mean, these are multi-billion companies, so they have to, there's a lot of investment at those companies, so they have to provide profit to their shareholder and stakeholder. But let me show you an idea. If you take here, if I've shown you that ChatGPT and the diffusion, the latent diffusion or the stable diffusion mechanism, they have some common theory, some common denominator, some common mathematical structure. If you think about this, and you remember that I had a short while ago a video on simplicial complexes, on graph neural networks, where I showed you in this video, if we go beyond the classical message passing in graph neural networks and we focus on simplicial complexes, on higher topological structures, let's say, in a topological space, or if you go in an abstract space, you have cell complexes. I show you here why we should go beyond graph neural networks, what are the problems and what are the possible solutions to this. And also another input I would like to show you here, I have a video on the neural semantic information retrieval system. And here I code with you a complete neural information retrieval system based on sentence transformers. And now you get the idea, I suppose, where I want to go with all of this. Because if you combine this information with here the graph approach, yeah. Now it's to, I have to do another video on graph, on the computation, on PyTorch geometric and DGL on deep graph library. One of my next video will be on the link prediction, but not in a classical low-dimensional Euclidean space, but we will go in a higher dimensional, more complex topological space. But I have to show you how to code this. Maybe I will make a video about link prediction in PyTorch geometric, and I show you the code on the other side of the paper in deep graph library, maybe in TensorFlow, that you can see that both frameworks are focused on the same idea, and that we need this idea if we want to have a technological discontinuity here in the evolution of ChatGPT and Stable Diffusion. So there will be a new video on PyTorch geometric about a higher dimensional topological version of this. And yes, I already showed you a document where it is not just about variational autoencoder, but about a higher topological diffusion variational autoencoder. But this is all the hints I want to give you. There will be a new video. I hope you enjoyed this one, and I hope to see you in my next video.